let's do some crazy talk. Let's start with futurism.com, all right? Futurism.com. It starts here. Scientists say space is filled with invisible walls. Huh. You don't say. Hey, you don't say. Hey, the scientists say it, right? Trust the science, right? We're told to trust the science, all right? So, hey, tonight, we're going to do something different, and we're going to trust the science. All right? And we're going to say, it's only half tongue-in-cheek, everybody relax, but we're going to go with invisible walls tonight, right? Because why not? All right, let's read a little bit of this, and we'll see what's going on with this. This is wild. Could symmetrons explain the existence of dark matter? Things get interesting, don't they? Very quickly. Here we go. Scientists' current best theories about the arrangement of the cosmos suggest that small galaxies should be distributed around their host galaxies in seemingly random orbits. But observations have found that these smaller galaxies arrange themselves in thin disks around their hosts, Vice reports, not unlike Saturn's rings. Needless to say, that represents a puzzling gap between knowledge and theory, right? Researchers are now trying to reconcile this gap by suggesting smaller galaxies may be conforming to invisible walls. You heard me, walls. W-A-L-L-S, invisible walls. That's right. Surrounding galaxies. This continues. I'm beside myself here a little bit. When I saw this article, I was like, what? Anyway, by conforming to invisible walls created by a new class of particles called symmetrons, a fascinating proposal that could rewrite the laws of astrophysics. The standard theory, known as the lambda cold dark matter model, suggests that the universe is made up of three key elements: the cosmological constant, which is a coefficient added by Einstein to explain his equations of general relativity; cold dark matter, which are slow-moving theoretical particles that don't emit radiation; and the conventional matter we interact with every day. All right. That's probably enough for now before we start to get really crazy on this. Now, look, okay, so I was thinking about this, and I'm like, all right, as you know me, I like to think, and yeah, I'm not a scientist. I'm not an astrophysicist. I'm just, like I always say, I like to demean myself and say, I'm just me. I'm just a knucklehead on the internet, okay? That's all I am, right? But I do like to think in terms of large things, okay? So if we have walls in space, invisible walls, actually, that sort of keep, let's say, galaxies in order, in some sort of like cosmic order. What the hell is really going on out there? That's the question I have, right? So there's a few questions tonight as we get going, right? There's the article from, of course, from futurism.com. And as usual, right, if in the name of transparency, not only do we have, again, open phone lines and all the rest of this and the Discord. And, if you're like, hey, Mike, you're off the rails, step back from the maybe juice. I'll be like, that's cool. Like that's part of a conversation. It's if you think I'm a little far out there in my theories, well, we like to press the envelope here and maybe think of things maybe a century before other people do. So that remains to be seen. History will be the judge of that. However, walls in space. Walls in space. What the hell does that mean? What does that even mean, right? So if we're talking about, gravity is, gravity is a magnificent thing. It's a great theory, Einstein, all the rest of this stuff. We're talking about Newtonian physics and the apple on the head and, right, the whole bit, right? The gravity wells that are created by these huge mass, let's say planets or moons or suns or black holes or whatnot, right? They're sort of in the gravity wells of space-time, okay? And what happens is, as a result of that, there's a hold, a gravitational bond between the object itself and the objects around it, okay? Based on that curvature of space-time, all right? Old school stuff. This is not brand new anything. But what they're talking about is in terms of a galactic thing. They're curious why, for instance, number one, which this goes back to Oumuamua fame, if you guys remember in the first known interstellar object that came into the solar system a couple years back, right? So interestingly, I was thinking about this when it happened. We have our solar system in a flat plane, right? It's literally just flat, meaning that we have the sun, and then we have everything kind of orbiting around it in a flat plane. It's not like this, or elliptical. It's not. Everything sort of tends to, even in space, coalesce gravitational-wise to the flat plane of a round object, we're told, right? A round object, in this case, would be the sun. Okay, and again, like I said, yeah. So anyway, there we go. So that's an interesting thing that I was thinking about way back then. I'm like, that's odd that gravity does that in a vacuum in space without those sort of things pushing and pressing against it, like it would here on Earth, the atmosphere and all the rest of the stuff, right? So anyway, they're saying that not just the solar system has a habit of doing that, but these galaxies, these massive galaxies, tend to actually sort of fit themselves into this flat plane of existence.